So how is your long break? You forget everything about school, right? That's good. That's a good break. That's why I have to start reminding you with this slide first. I guess just before the break, I mentioned that I was away. I was going to give you some work in class, but decided not to because many of you did not do well in the midterm. So some of you probably have dropped the course already. It's, I guess, disheartening for many of you to find that, well, the minimum score was 5 out of 70, but someone did get 63, so it's a big range, large range, very wide range. So I just decided to let at that point I go over the midterm with you to make sure that you have some understanding at least, because otherwise you will have problem in the final for sure. What I suggest for those of you who have problems, or everybody in general, trying to get a copy of either the textbook or the reference book. It's going to help. It's going to take a lot of effort, but it's not that bad, I think. This reference book is the most difficult to read, so if you cannot get anything else, get this one, but if you have a choice, do not get the one by Rosen. Rosen is the one actually used by everybody else, but it's quite difficult to read, especially for Thai students, I think. But at least it's got all the material covered in there. So there's a lot of self-learning on your own, studying and trying to understand what we present in class. We only capture basically parts of the textbook. We don't cover everything. We already not include the more difficult parts because it's a first-year class. So trying to get a copy from the library if you can and study it. If necessary, you can come to me, or at that point in time, maybe we have a spare copy you can borrow for a period of time. The other thing is, do you actually go to the e-learning system? Do you watch previous lectures? Has anyone watched previous lectures? No? Okay, because if you do, you'll find that there will be a problem with my lectures for some reason. Maybe because my voice is softer. You hit a lot of static, there's no voice. I need to talk to them. I just found out yesterday, actually. So I guess it's not a source for you to try to understand material again because you cannot. You just have to come to class for now. But we're trying to figure that out, why there's no sound. It's fine when Ajahn Ponchai is teaching. You can hear his voice, but you cannot hear my voice. It's very strange. Well, that just means you have to come to class and listen to me. That way you learn. Even, better way to learn than trying to go through the video. Okay, so just as a reminder, since it's been a long time, we're talking about combined torics, basically combinations. And we have 4 types of finite structures. If the order matters, like A, B, C, D, A before B, before C, before D, or B, C, D, A, for example, if it doesn't matter, then we have this category. And then, do we allow repetition or not repetition is allowed? Repetition means you can have A, B, B, for example. So you have more than one A. No repetition means only one A, one B, and so on. Okay, so just to remind you, we have these. If it's order, repetition is allowed, then we have order list. If order doesn't matter, repetition is not allowed, then we have a set. So this is basically what we cover from the beginning when I talk to you. We talk about sets. So where I left off, was back here. So we ended with this problem. We asked how many k-element subsets of this set. So the set is 1 to n. 1, 2, 3, 4, 5, the integers from 1 to n. And we want to pick k elements, which is less than or equals to n, from this set. So the solution is basically, previously we talked about permutation, but now what this is posting here, this problem is actually a combination. So we use the symbol C. So it's a combination of n choose k. So previously we have the permutation of n choose k. Now it's a combination. And what this is, simply the permutation divided by k factorial. So in other words, just n factorial divided by n minus k factorial divided by k factorial. So this is something you have seen before. And that's something you can use to count or determine the number of ways to choose k things from n choices. So n choices here could be the whole class. If I want to pick randomly 2 of you to come up here to work on some problems. So let's say how many people are here today so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 24. So what's 24? The combination of 24 choose 2. You can calculate that. Let's start with a simple mental exercise. Some large number. So it's a large number. I have many choices. So you can check my arithmetic. Is that correct? Ah, good. So somebody's awake, good. Have to give you something to look at and see if you can find some problems. All right, so 276, still a large number, right? So now we have male and females in the class. So you say I want to pick one male and one female to come up to the board. One on the right side, one on the left side. How many females do we have so far? 1, 2, 3, 4, 5. 5 females and 19 male. That's even easier problem, isn't it? So this is just 5, choose 1. And what is that? 5. 5 ways, right? And this is 19, choose 1. It's just 19. If I want to choose one male, one female to come up to the board to work on some simple exercise, I have 5 choices for the female and 19 choices for the male. That's what we expect. So there's some very simple, easy exercise here that I would say, I would ask for volunteers, one male, one female. Advantage to the female because I'm asking you to come up here to work on these problems. Give me the answer. If you get them right, you'll get a very easy bonus mark. So only if those of you who might need a bonus mark come up because it's very easy. Anybody want to volunteer and come up? It's a very easy bonus mark. Very simple problems. We have one more female coming in. I'm asking for one female, one male to come up, volunteer, to work on these problems before the rest of the class come, which they usually come late. Maybe all of you are here already, I don't know. Hurry up. This is your chance to get a free mark. Anybody? I'm sure some of you could use a bonus mark. Nobody want a bonus mark? Come on, it's a very easy bonus mark. No? Okay, someone's coming up. Good. So you're on this side. You can just erase this. All of them, so easy. Okay, we have 6 female. Anybody want to come up? You're not going to wait for the answer before you come up, are you? Any female want to come up? Nobody? She's coming up? Okay, good. Please, just pick a marker, erase the board, and just write on there. There should be a eraser on the other side. When it's on Pointai lectures, does he use this microphone or this microphone? Do you remember? He used this one too, right? Okay, just my voice, for some reason, is not carrying it. It's not picking up. It's too much static. Then I have to go like this. Well, maybe if I button this way, let's try. If I button this up, is this any better? The same, or does this sound better or not? It's a bit louder, right? Is it? No? Sounds the same. So I don't have to button up. Now, how do I take it out? Are you sure it sounds the same? Okay. Okay, could you write your name there, please? Oh, you have to go back? Just one sec. Why do I have a problem here? You finished? Yep. Okay, good. Write down your name, please, and number. Okay, I'm having a problem with Edmundo here, but so go to this. Instead of having a problem with the Moto on the computer, so to take attendance, go to this web link and answer the questions A, B, and E. The answers are here, but choose the one you think is correct if you want. Or if you work on it by yourself, then you use it. Okay, I actually just posted on a Moodle as well for my notebook. Are we all done? No? You can just go to Moodle and click on the link then, if you have a problem typing this. Should be here, but I have a problem with this. Someone just came in, maybe. You better go to a Moodle and answer this. You have your choice of, let's see if it's the same. 30, 15, 15, 1, and 1. Okay, same answers. Don't you wish a midterm was as simple as this? Then you all get perfect. Well, if you study on your own, you can get much better marks if you want to. All right, 2 more minutes and I'll close it and we'll continue with the lecture. Actually, today is mostly working on problems. I decided not to have 3 lectures on graphs and trees, only 2. So today we just finish off this chapter and work on the problems to make sure you have good understanding how to solve these problems. So how many of you actually went outside Bangkok during the long break? Anyone? I think most of you did. Did you go back to your hometown, or some of you? Then you went outside Bangkok, right? No one put their hand up except me. Actually, I didn't go outside Bangkok. 1, 2, 3, 4, 5, 6. Good, we're seeing some hands. Did you stay in Bangkok? Oh, you got a chance to go around? Not much traffic, right? Except at the mall. If you go to the shopping mall, it's very crowded. Okay, I'm closing it. Okay, let's continue. So let's work on some practical, easy problems, I think. So it's very similar to what I just getting you to come up here, like male and female. So we have 9 men, let's say, and 12 women. In this case, it's a math club. You all love math, right? Math is so fun. Math is a 4-letter word, by the way. Well, the math club members decide to form a fundraising committee. They want to raise some money for activities to promote mathematics, to help people to learn about mathematics. That's a very good cause. So how many possible committees of 4 people can be formed? So how do we answer the first question? We want to pick 4 people to form the committee. So how many different combinations are there? So that's very simple, right? So we have, how many people do we have? So you have to read the question, read the statement, and pose the problem. So how many possibilities? What are the total number of people? The total number is 9 plus 12. There are 21 people, right? In total. And we want to choose 4. So simply, combination of 21, choose 4. So the answer is very simple. It's just combination of 21, choose 4. And you can calculate that for the first part, right? How many possible committees of 4 can be formed? So there's no restriction on male or female. We just ask 4 people. And there are 21 of them. So second case, now we want to put a restriction. We want to have same number of women and same number of men. So women and men have the same representation. So what does that mean? So you can look at it several ways. Well, you have to say equal, or you can actually look at the number. Equal means, since there are 4 committee members, equal means 2 and 2, right? So in other words, 2 female and 2 male. Okay, you have to read it, understand it, and then try to see what's the easiest way to solve it. The easiest way is to look at it as being, you want a committee to have 2 female and 2 male. So again, it's very straightforward. So how many females do you have? 12. So we have 12, choose 2, plus, no, not plus, what is it? We're doing combinations, it's a product. Product rule, times. How many men? 9, choose, combination of 9, choose 2. So we have this many and this many, we multiply them because it's a combination, that's a product rule. So it's a matter of reading the question and understanding it. Then it's very easy, right? Okay, so we want, so in this case, this is female, this is male. This is female plus male together. So the last case, how many 4-people committees have more women than men? So if you look at the wording, you want more women than men. So what are the cases with more women than men in a 4-person committee? So that means 3 women, 1 man, or 4 women, right? So we have 2 possibilities. So it's either 3 women plus 1 male, or 4 women would satisfy that condition. So in that case, how do we do this? For 3 women, we have 12, choose 3, 1, and then we have 9, and we choose 1. So that's this case. 3 women, 1 male. And for 4 women, it's just 12, choose 4. If you want, it's 9, choose 0, but it's the same thing. And then we just add them up. So we use a product rule and the sum rule. In this case, we have 2 instances, 2 possibilities. One is 3 and 1. The other one is 4 and 0. So to add it, to say how many, we just add them up. Is that clear? You have to try and look at it and understand what I was trying to do here. Then it would be easy for you. But if you're not paying attention, then you will have a problem because you may misunderstand the context and may not know how to approach the problem, how to solve the problem. But if you look at it systematically, step by step, it's very simple. Okay, he came back just in time for practice. He's got his drink. Okay, we have 3 questions here, A, B, C. So instead of 2, male and female, we have now 3 classes. Red, green, and blue. Okay, so 5 red, 3 green, and 8 blue. And we put all the marbles in a box. So the first question asks you, in how many ways can a sample of 4, again we want to choose 4, be selected without replacement, without regard to order? So order doesn't matter. In other words, you're just reaching in this bag and pick 4 marbles. It doesn't matter if you pick the red first, if there's a red. Okay? So how many ways can a sample of 4 be selected? All right, so more bonus marks, easy bonus marks. Actually, not as easy, but not difficult. So I open this to anyone. I'm not going to say male or female. We have 3 parts, A, B, C. So work on this. If you think you can do it, come on up. If you get it correct, then you get a bonus mark. If you don't get it correct, then consult with your friends. Make sure, trying to improve your chances of getting it right. So think about this as analogous to the previous example. We have male, female, 2 classes, so 2 categories. But now we have 3. Red, green, and blue. It's almost like Pokemon. Pokemon has red, yellow, and blue. This is red, green, and blue. Anybody need some paper to work on? Anybody else? Yes? Oh, some writing on there. I'll go get some more paper in case you need it. So work on those problems. If you think you have a solution, you're not able to do it, come on up first. Pick the one you want, A, B, or C. and start working on the board. Okay, maybe I should put one restriction. If you already have a bonus mark today, let someone else have a chance first. I have more paper, just in case you need it. You'll need it for later, maybe. So similar to the example I gave you in the previous slide, we want to choose 4. In this case, we have 3 classes to choose from. And order doesn't matter. You're not volunteering? So, but there is a difference between this and the previous example, right? In the previous case, 9 men, 12 women, but each one is distinct. So even though there are 9 men and 12 women, but each man is different, right? But in this case, 5 red, 3 green, 8 blue, each red is the same. It's not red 1, red 2, red 3, red 4, red 5. So there is a difference. So it's not the same as just adding them up. You cannot say 5 plus 3 plus 8, which is 16. 16, combination of 16, choose 3. No, or choose 4 doesn't work. It's not as easy as that. There are different ways to solve it, easier way and harder way, but you'll still get the solution. Well, even though I'm asking you to look at A, there's also B and C. I can tell you part B is much easier than part A. If you want to do part B and get the simple marks, go ahead. Don't have to do it in order. You can look at all 3 parts, A, B, C. I can tell you part B is a lot easier than part A, or at least to me. So you don't have to get stuck on part A. Just like in the exam, if a question is difficult or you think it's difficult, go to the next question or next part. Don't get stuck. See if you can do the next part, next question. Do the things that you can do first. Okay, so look at A, B, and C. See if you can do any of these. If you think you can, come on up and give a solution. And if it's correct, then you get a bonus mark. And no restriction, like I said, if you get high grades, high marks in midterm or not, you can come on up. Read it carefully. Don't you think part B is easy? I don't know. Seems very easy to me. Okay, the other thing is, this is a question asking you this, but I did not ask you to do it theoretically or elegantly. In other words, worst comes to worst, use brute force. Go through it one by one. There are not that many combinations. I mean, a question like this, there are finite cases. You can count them. I did not ask you to answer this in an elegant way or mathematically present it. I just asked you for the answer. So if you're stuck, like I said, with something like this, the number's not large. 5, 3, it's large enough, but not that large. So you can actually manually list if you like. That's what I mean by there's more than one way to solve certain problems. Anyone want to give it a try at all? At least? Anybody have any questions? Do you understand this? More paper, lots of paper. They're not distinct. You cannot distinguish one red from another red. You're assuming you can distinguish, but you cannot. Red marbles look the same. Sorry?
B. Answer is 2 1, right? 2 1.
Go up there and write it down if you think that's... At least you get a chance to get a bonus mark. Don't ask me. Try to go up there. Come on up. He's going to give an answer for B. Come on up. Come on, write something down. Yeah, red is the same. You cannot tell the difference between one red and another red. It's the same. It might also depend on your interpretation of the question. So if you're answering, trying to put down your interpretation, then you might get at least some part marks. What do you think this means? Then you answer it. That's why I asked you, do you have any questions? Okay, can you explain why it's 2, choose 1? Let's see if this works.
I think it's 2 1 because for each color is the same. For example, 5 reds for each red is the same. Okay. Yeah. But in the green, it has a tree. It can have it can select for right.
Do you understand his reasoning? So basically, how many all 4 selected the same color? So how many colors are there? Red, green, and blue. Only 3 colors. But since green only has 3, if you choose 4, it cannot be all 4 green. So that means it's either red or blue. So So 2 choices, and you choose 1 because how many ways? Basically, you're saying 2 ways. Okay, that's correct. Write your name down, please. So like I said, this is the simple part. So if we have 4 greens here, then this answer will be 3 because we can be 4 red, 4 green, or 4 blue. But we only have 3 green. So we cannot have 4 greens. So it's either 4 red or 4 blue. So 2 different ways. 2 ways. Okay, the easy part is gone. Now the other 2 parts. It's not necessarily difficult, but like I said, you can use brute force. List them one by one if you want. So red, blue. Okay, this is my green. One possibility. I mean, how many ways do you need to count? So we have 4 marbles. It can be, say, red, blue, blue, green. Imagine this is green. Or change that to black. Doesn't matter. So you have 4. So how many of these are there? You want some paper to list it out? It takes less than 1 page. Anybody have an answer? Well, if you use brute force, okay. If you use brute force, part C is not that long. He's doing A. Okay. Okay, sorry, that's not correct. Doesn't matter. P or C is still not correct. Thank you. Thank you for trying. The reason is because you cannot tell the difference between one blue and the other blue. Blue is blue. But when you have men and women, each person is different. But in this case, each red color is the same. Well, part C is relatively easy, not difficult. Not as easy as B, but easier, shorter, fewer numbers than A. Come on. So read the question. It says, let's look at part C to make it easier. How many have two colors? So how many colors are here? 1, 2, 3. So this is not two colors. So what can we do for two colors? Two colors can be red and blue, can be blue and green, or, whoops, red and green, right? If you want two colors, the two colors can be red and green, red and blue, or green and blue. So consider them as separate cases. Consider this, how many, and add them up. So how many? Well, the part that's not here is you have to consider that's the only other thing you need to know. So when it's two colors, it can be 3, 1, 2, 2, or 1, 3, right? When they're two colors. Not 0, 4, not 4, 0, there's only one color. The answer is right there, come on. If you can answer it this way, then you can answer it this way. It's the same, using the same logic. I just gave you the answer. Come on, think about it. Part C. Is it too easy a mark to get? I mean, if you don't want an easy mark, we can move on. Someone just give me an answer, we can move on to the next part. How many people have an answer but don't want to come up? No one want to put their hand up? No one want to admit? Just scrap the easy one. Come on, let's move on. I just gave you the answer. 3 cases, and each one has 3 cases. Like, how much easier can it be? Okay. Question? Yeah. Question? You go up and write on the board, then I'll comment. Why not? Okay, what's the reason? What's the reason? So 3 different colors? Right?
For blue and blue, green, blue.
Red
Yeah.
and green and blue.
3 cases, and then add up.
Okay. So what does this do? You said 5, choose 2. But the question is 5 red. Can you tell the difference between the 5 red? No, right? When you do this, it means you can tell the difference. You said 5, choose 2. 5, choose 2 means 5 red balls, you choose 2 of them. But it doesn't matter which 2 you pick. It's the same. So it's not this, not 5, choose 2. Look at what I did on the left. Is it really that early in the morning or early after the break you cannot think? So this part's obvious. There are 3 combinations. It can be red, blue, green, blue, or red, green. So whatever the answer for each case, you multiply by 3, or just add them up. Anyone paying attention to what I just said? Because I just gave you the answer, exact answer. Do you understand?
The 3 cases. So 3, 9,
Write it on the board. Go write it on the board. She's doing part C. Okay, should I explain to you?
This is group of 2 colors. So we have 3 group of 2 colors. And for each group we have 3 cases. So it's total 9.
Sounds reasonable? Okay, write your name down. Actually, the answer is correct. It is 9. As simple as that. 3 plus 3 plus 3. Now can you do question A, part A? Understanding this part. If you understand B and C, you can do A. Just a longer way to go. Again, you can separate into cases. So instead of looking at this, what you want to look at actually is how many colors are there in a sample of 4. It can be one color. It can be 2 colors. Or it can be 3 colors. You already have the answers for 1 and 2. So find the answer for 3, add them all up, and you get part A. Just because we put part A there first doesn't mean you have to do part A first. It turns out in this case, it's easy to do B and C first. But if you know the reasoning, you can do part A, of course. Okay, think of it as number of colors. You have 4 marbles you picked up. How many cases are there? Case of all 4 same color, have 2 different colors in the 4, have 3 different colors in the 4, so 3 cases. You don't have 3 colors, right? There's no 4 colors. So you can have either 3 colors from the 4, 2 colors from the 4, or just 1 color of the 4. So you already done the 1 color, done the 2 color. Now do 1, 2, and do the 3 color. Add them up. You get this. Anybody want paper? It's not difficult. Work it out. Get a solution. Get a simple bonus mark now. Come on, you can make it before the break time. This board is clear. So you just break it down into sub-problems. It might be too complicated, then you break it down into this, work out each one, you'll get a solution. Okay. Oh, the marker is there. Please. Not really. Think about it. Think about this. So this is 3 colors, right? This is one case of 3 colors. You can use British or American spelling, doesn't matter. This is 3 colors. Is this only one combination? I mean, this is red, blue, and green. So, how many? It's almost there, but think about this. You have one of one color, and one of with 2 balls of the same color. Just think about it logically. You have 4. With 3 colors, that means one color will have 2 marbles. So how many cases are there? You're getting there, almost there, almost there. You just have to consider, you give me one answer, you give me this. For example, you give me this. For blue. But you have how many colors? How many colors do you have? How many colors do we have? Okay, 3. So that means this can be blue with 2, could be red with 2, or could be green with 2. So, how many? No, this is one case. This is one color. So again, say this is, put this as blue. Blue color. Yeah, blue color. And then now you do green and you do red. Green, red. Okay. Just continue. So what do you do with it? Okay. I'm asking you, is that right? Does it look right? Does it look right? You have to say, yes, it's right.
Yes, it's right.
Okay, you can write down your name too. It's not that difficult, right? Just break it down into smaller problems one by one and solve it. Okay, we're taking a break. So you can absorb this. Make sure you understand this. It's not that difficult, really. Okay, we can come back and continue the lecture. You're welcome to come up to take a look at these books if you want, just to see. Because there's a lot of material in it, especially in this, because we're based on this textbook. Sorry?
I come late to
Okay, we should start again. Okay, I'll get started anyways. Just a correction for part C. So one of you came up to me afterwards and said, the answer is not quite correct. That's because we have a second constraint that the answer initially did not take into consideration. The second constraint is that the two of each color, that means of the three cases, you actually only have one case. Two colors, equal numbers. Not three choices, but only one. So it's actually 3 times 1, which is 3. But we still have 9 here because for 2 colors, the other answer was correct. We have 9 cases. 3 combinations of colors, and each color have 3 cases, so we have 9. So that is correct for 2 colors there. But because of the second constraint in part C, how many colors of 2 colors? Fine, we have 9, but then second constraint with 2 of each color. So 2 of each color, that means it's only 1 of the 3. This have 2 of each. This is 3 and 1. This is 1 and 3. So the correction to part C, because of the second constraint, so the answer is just 3. Okay, let's move on. So now let's look at another example. So we're going to consider a coin toss. And we're not going to, it's going to be either head or tail. We're not going to worry about it landing on its edge. It's possible, but it's a very slim chance. So we just assume it's either head or tail. And we assume it's 50-50 chance. Assume it's a fair coin. So these are assumptions you can say. So we're going to do 10 consecutive tosses of a coin. We take a coin, flip it 10 times. We want to know how many different ways can we have 5 heads. So we toss this 10 times, and then we'll put 5 heads here. We can put it 5 at the end, 5 at the beginning, 5 in the middle, or just interdisperse it. So all we're doing is actually, in this case, 10 experiments or 10 tosses, and we want to choose 5. Because order doesn't matter. I mean, the 5 are indistinguishable. The order matters in the sense that, where the head will go. But each head, you cannot tell one head from the other head. So it's just a combination of 10, instead of 10 tosses, and you're choosing 5 heads. So this is clear because it's a binary case. Two outcomes, heads or tail. So it's actually a binary case here. So you can consider that to be heads, 1, 2, just pick 5 places. And then the rest of them is the other case, which happens to be tail. So only 2 outcomes. Heads, or you can say not heads. So we can think of the second case as being not heads. So we have 2 choices. Either heads or it's not heads. So this simple answer is just 10. Combination of 10, choose 5. Because we want 5 heads. So that leads us to examples for binary sequences. Consists of two symbols. So heads and tail, 0 and 1, pass and fail. So these are called binary sequences. So the number of binary sequences of length n, let's say we have n. In our last example, we have 10. Length is 10. We have exactly k ones. In this case, we have exactly 5 heads. It's simply combination of n, choose k. So this is the answer to the previous example. Very simple. Combination of 10, we choose 5. Now, on something related is what's known as a Pascal's triangle. Sometimes it's termed arithmetic triangle. So instead of Pascal triangle, you also hear the term arithmetic triangle. Or that's why it says here AT. AT stands for arithmetic triangle. So it turns out the combination of n choose k is basically the kth row and the nth entry in this, what we call Pascal's triangle. But what you should note is that the row number, or n and k, starts with 0. It doesn't start with 1. Because just like, you can choose 0, right? How many items you want from 1 to n? You can choose 0. So 0, 1, 2, 3, 4, 5. So these rows starts with 0. So for example, 6 and 2. 6th row, 0 row, 1st row, 2nd row, 3rd, 4th, 5th, 6th row, and the second column, 0 column, 1st, 2nd is here. So this entry, 15, is calculated by simply taking combination of 6 choose 2, which is 15. So if you follow this, you can use it to build this, what's known as Pascal's triangle, or arithmetic triangle. Okay, so many of you probably have seen this before, at least this kind of structure, and you might have heard the term Pascal's triangle, basically, or Pascal's arithmetic triangle. Okay? So this is also related because it's simply each entry is C and K. Now, binomial theorem, you can actually extract from, it's also based on Pascal's triangle. What is specified is 1 plus x to the power n. So to power 2, to the power 3, and so on, we can expand it out. And what's interesting is the coefficients of the base term, x to the 0, x to the 1, x to the square, or if it's x to the n, the coefficient is simply given as entries in the Pascal's triangle, or combination 2 and 0, because it's power 2. So in this case, we're looking at let me write it here. So you can generalize this to be 1 plus x to the n is c n0 plus c n1x plus c n x to the n. Okay, so this is known as binomial theorem. It's basically 1 plus x to the power n. And that, again, is just combinations. The coefficients for each term happens to be c n, in this case, 0, because this is x to the 0. This is x to the 1. This is x to the 2. And this is x to the n. Okay, so it's binomial theorem. I think you have seen this before. So it's a simple practice. Coefficient of Z5 in the expansion of this. That should be easy, right? So think about what I just did here. So in this case, n is 8. And this is 5. So very simple. This is C, 8, choose 5. Right? Very simple. Second one, so to make it a little bit more complicated, instead of Z, we say 1 plus 2x. So to make it a little bit more complicated, but it's the same thing. So all you have to do is just say, let z equals to 2x. Then you can say 1 plus 2x to the 7 is equals to 1 plus z to the 7 if you want. Then you have the coefficients for z, but you want coefficients for this. Then you substitute 2x back in. So for one plus z to the 7 and the coefficient of to the 4, that would be 7 choose 4. But not z, you have 2x. So that means you have 2x to the power of 4. So in other words, you have this. You have to multiply this by 2 to the power of 4. Okay? So in other words, we replace this with, if this is 2x, then this is 2x, and this is 2x to the power 2. This is 2x, then this is 2x, this is 2x to the power n. Right? So if it's x to the power 4, that means 2x to the power 4. So you have to multiply this by the coefficient 2 to the power 4. To find the coefficient. In the last case, again, just a slight twist or slight deviation. Instead of x or z or x or 2x, we have t squared. And he asks you for t to the power 6. So what that means is you have to factor it in. So t to the power 6 is equals to 2 to the power 3 squared. Or in this case, actually, we should write, this is t squared there. Let's do it the other way. Sorry, 2 squared to the power 3. Right? So if you're expanding with respect to t squared, that means we're looking at the third. So for this case, it would be a combination of 9. Choose 3. Guess we have to express it in form of t squared. So if you know this trick, so-called binomial theorem, then you can actually answer this very easily. The only trick is that we have replaced t squared. Instead of x, we have t squared. Instead of x, we have 2x here. Okay, so you just have to read the question carefully. Look at the coefficient of this term, x to the 4th. You get it from 2x to the 4. That means you have extra term, 2 to the power of 4. Okay, so look at it. See if you understand it. If not, take a little bit more time trying to look at it step by step. You can substitute in the variable if you like, to help you to understand. Okay. So we talk a lot about combination of n choose k. Basically, we can use it in any of these circumstances to get the answer. First one is basically a k-element subset of a set of n elements. So this is this basic way to derive this. But it turns out to be the same as the number of ways to choose k things from n things in general. Or if you consider binary sequences, 0, 1s, pass, fail, heads, tails. So sequence of length n is exactly k 1s, and it's 0 and 1. Or the entry of k in row n of Pascal's arithmetic triangle we just talked about. Or in the binomial theorem expansion, the coefficient of each of these power terms. Okay, so all of those we can simply use combination of n choose k to determine. Okay, so let's look a little bit more about binary sequences. So we mentioned that we can use combination of n choose k to find a number of ways to choose k things from n things, or exactly k number of 1s in a sequence of 0 and 1s. So let's look at some examples. That's how we can make use of this. So how many different arrangements of the letters in the word Mississippi? Mississippi is a state in the U.S. It could be another name for a city or elsewhere as well, but definitely it's a state in the U.S. So to answer the question, let's work it out systematically. So Mississippi, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, right? So we have 11 letters. So we write down 11 number blanks, and then we'll work through this step by step. So similar to what we just looked at before the break, we have red color marbles, blue color marbles, green color marbles. So in this case, how many different letters are there? We have M, we have I, we have S, and we have P. So we can approach it exactly the same way. We have M, I, S, and P. So exactly, there's actually one M, 4 I's, 4 S's, and 2 P's. In particular, if you look at this, if you don't know Mississippi, which many of you actually do not know, so you look at this as a word, English word, or alphabets of characters. So it consists of one M, 1, 2, 3, 4 I's, 2 P's, and 4 S's. So the question is, how many arrangements of the letters M, I, S, P in this word can you actually make? So it's very similar to the question when you draw out the 4 color marbles. So how do we do this? Choose one of 11 blanks to place the M. So simple, right? 11, choose 1. Is that right? Then next, after we choose, put an M here already, we have 10 available blank spaces. Because 1's occupied by M. So there are only 10 places left. So now, we want to choose 4. So combination of 10 blank spaces, and we want to choose 4 for the I. And after we choose 4, we have 10 minus 4, or 6 blank spaces left. Then we'll do choose, combination of 6, choose 4. And if we choose 4 from here, we only have 2 left. Actually, remaining is 2, choose 2, which is just 1. One choice left. So now what do we do? Do we add or multiply these numbers? Let's multiply. So we have this, multiplied by this, multiplied by this, multiplied by this. It's a product rule. And we get the answer. Right? Simple. So again, you break it down into smaller problems. You look at it, say there are actually 4 different alphabets in here. And there are M, I, S, and P. And then we think about, there's only one M, where to put the one M, and so on. Now the question to you, does it matter if choose M first, or can we choose this first? It doesn't matter, right? The answer should be the same. And you can show that yourself. Okay. Similar question, instead of Mississippi, another state in the U.S., Pennsylvania. So it's the same thing. How many alphabets are there, letters are there? We have P, 1P, 1E, 1, 2, 3 N, 1 S, 1 Y, 1 L, 1 V, 2 A, and 1 I. More letters, but same process. Right? So we can just use this. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we happen to have 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters. So we use the same approach. And you can answer this, right? What about the second part? How many distinguishable arrangements are there of the letters in the string 100100100? So this is a 1, it's not a bar. It's a binary string. It consists of ones and zeros. So what we need to know is 1, 2, 3, 4, 5, 6, 7, 8, 9. Length is 9. There are 3 ones and 6 zeros. So how do we answer this one? It's answered before already, but ask again here. What's the answer for part B, for part 2? Practice question 2. It's a binary sequence. So how many distinguishable arrangements to arrange a binary sequence? Well, the answer is given to you here. The answer is this. Number of binary sequence of length n, in our case is 9, with exactly k ones. We have 1, 2, 3 ones. So it's very simple. Combination of 9, choose 3. That's already answered. Okay, question 3. We put more constraints, more words, you can say. How many properly written numbers use every digit exactly once? And then it's 2 parts. Once, exactly once. How many use every digit exactly twice? How do we answer that? Or what's your understanding of this question? you have to write down your interpretation of the question first, maybe, in this case, to make sure you're answering the right question. At least you answer your question, what your understanding of the question is. What did we do in 3? How would you interpret this? So how many digits are there? What is a digit? Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That is a digit. Zero is a digit. And you ask how many properly written numbers. So what that means is, if your number starts with a 0, you don't have that. It does not start with a 0. Because normally you don't write a 0. If the number is 5, you write 5. Normally. But you could write 05 if you want in a month. But that's, let's say you interpret to be proper way, you don't write the 0 in front. That means we do not count the case with 0 starting in front. So how many digits are there? We have 10 digits, right? And we want to use each digit exactly once. That means the number has to be a 10-digit number. 10 digits, we want to use each digit exactly once, but not with the 0 in front. With the 0 in front, you actually only have 9 digits. So that means we will have a length of 10 digits. And we want to place the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 into this 10 blanks. How many ways can we do that? So there are 10 digits. And every digit is used exactly once. That means it has to be a 10-digit number. The only constraint is that this cannot be 0. Because we have properly written numbers. So we don't put a 0 in front. That's the only constraint. So how many different arrangements are there? 9? Only 9? You have to break it down. Come on. We have 10 digits, right? We have 10 digits. So what do? We just go through this one by one. First blank. What can we put in there? How many choices do we have? We have 9 choices because it cannot be a 0. So second one, how many choices we have once we choose one? Third one. Seven, 6, 5, 4, 3, 2, 1. So what is it? Equals to 9 times 9 factorial, which is whatever it is. Isn't it? Just look at it, break it down the problem. 10 blanks, you have to fill it in first one. 9 choices. 1 of 9, second one is 1 of 9, and so on. So you have to break it down, understand the question, and then the answer is not difficult. Can you understand this? First one, we have 9 choices, 1 to 9. It can be 1 to 9. Only, it cannot be 0. Only 9 choices. But the second one, after you pick one of the digits, there are only 9 digits left. It can be any one of the 9. And then 8, and then 7, and so on, right? So if you look at a problem this way, it's not difficult. So I wrote it this way because this is the first position. First position, we have 1 of 9 choices. And then the remaining 9 positions, the answer is 9 factorial. So in other words, just 9 times 9 factorial. Okay, I think you're warming up, getting a better understanding. Okay, so let's look at another problem, slightly different angle. What is the number of outcomes of a series of 10 games between players A and B? So there's a second condition here. So we have 2 players playing against each other, A and B. So let's make an assumption here because it's not specified. So the assumption is that someone has to win. Cannot be a tie. But if you want, you can put tie in here because we didn't say there should be a tie now. So assuming they play a game and someone wins. So either A wins or B wins. And they play 10 games. So in this case, we can consider it to be binary sequence because it's only 2 possibilities, A or B, will win. So we can consider if A wins first, we put A. If B wins next, we put B, and so on. We could put a sequence of length 10, and we have either A or B to indicate the player that wins that game. The additional constraint condition is that A wins more than half the games. So what that means is half of 10 is 5. So more than 5 games. That means A wins 6 games, or 7 games, or 8 games, or 9 games, or 10 games. So we just break it down into multiple cases. So for 6 games, we calculate 7 games, 8 games, 9 games, 10 games. We just add them all up. Okay, so Again, not that difficult. Just to break it down, understand the question, and then answer it. Okay, so similar concept, but this part maybe you should try to pay more attention. It's a little bit different, but similar. We're going to look at unordered list. We're not going to worry about the order. Things you're buying grocery, you're buying fruit, for example, and you put them inside a bag. How many ways can you buy 10 pieces of fruit at a store that only sells apples, bananas, and cantaloupes? A, B, C. So you denote as A, B, C. Okay, so the constraint is that you have A, B, and C, and total is 10. So it's similar to the problem you have seen before, right? Now we're going to use a different approach to solve this. Okay, so example, we can have 3 apples, 3 bananas, and 4 cantaloupes, or no apples, 9 bananas, and 1 cantaloupe, and so on, or all cantaloupes. So these are just examples of possible cases. We want to know how many of these possibilities are there. Okay, so we'll use a slightly different approach than before. In particular, we're going to make use of binary sequences to solve this. So when we look at a problem before, we use a different approach, but we can make it more structured. We can look at it as a binary sequence problem. What we're going to do, we have 3 types of fruit: apple, banana, cantaloupes. We want to see, we indicate each of these with a 0. But the trick is, we'll bring in a separator. And the separator is a 1. So this is a structure. We want a number of A's, and then we put a 1 in. Number of B's, put a 1 in. And the number of C's. So if you look at this example, 3 A's, 3 zeros, 3 0 0. Then we put a 1 in, separator. How many bananas? 3. Then you put down 3 zeros. And then we put in a separator 1. How many cantaloupes? 4. 1, 2, 3, 4. So now we have a binary sequence, which is very easy to solve. Okay, so look at these examples, make sure you agree. In this case, no apple, so there are no zeros at the beginning. So we have a 1 because no zeros from A. And then we have 9 bananas. And then put the 1 in, and then 1 cantaloupe. And in this case, we have no apple, put a 1 in, no banana, put a 1 in, and all 10 of them are cantaloupes. So we approach this problem in another way. We treat it as a binary sequence. Because we have 3 different types of fruits, we have 2 separators. If we have 4, then we have 3 separators. So when you treat it this way, then it's actually very simple. The answer is very simple. It's the same as the number of binary sequences of length 12 that have exactly 2 ones. Because each of these cases have 2 ones. So we have 10 fruit, 10 pieces of fruit, but we add in 2 separators because there are 3 types of fruit. If there are 4 types of fruit, then we put in 3 separators, and so on. So the total length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and 2 ones. Each length is 12. So the answer again, length 12, we want exactly 2 ones. The answer is 12, combination of 12 choose 2, or 66 ways to get the 3 different types of fruits, and you want to buy 10 of them. So I told you at the beginning of the class that there are many ways to solve this kind of problem. This is another way. You're just basically transforming the problem to be a binary string. And if you do that, then the answer is very simple. Okay, so we're making use of the concept of binary string, which is easy to solve, and we basically pose the problem in form of binary strings or binary sequence. And we're not worried about a proper sequence now. We can start with zeros here. So we just have a sequence or string. We can call it string then, because strings can be 0 and 1. Okay, so we get lots of time for one last practice to do in class. So we'll make a slight change. 1, 2, 3. This in-class assignment, you use paper. Slight change. Write it down. I'll give you paper. Put your name and number on there. You use paper to write. It's in-class assignment, not a quiz or test. It's an assignment. And when you finish, you can go. You might go. If it takes longer to finish, then you have to stay longer, I guess. Or you can stay as long as I stay, I suppose. You have, okay, fine. You use the other side, okay. You have the other side. So there are 3 questions here. it's in-class assignment. That means you have to submit it at the end of class today. So something different. You have to write it. Writing is actually good. Give you good practice. If you have any questions, raise your hand and then I'll try to answer it. Again, read all the questions. Do the ones you think you can do first. Don't spend too much time on something that you are stuck on. I'm sure at least one of these questions you can work on faster than the others. So this is an in-class assignment. That means you're free to talk to your friends or discuss this. It's not a quiz. But you do have to submit it in about 20 minutes because that's end of class. If you understood what I said just before this on the bag thing, you can answer question 2 in 10 seconds. Okay, class is almost over. I guess I can wait a few more minutes, but officially it's over in 30 seconds.